Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning exercise 2.2 from the chapter Polynomials. So in this exercise, we have two methods. One is one equation of polynomial will be given and we will be finding the zeros and we will be verifying with the relation between coefficient and zeros, and the second method is the solutions will be given or the zeros of the polynomial will be given and we have to find the quadratic polynomial. Okay, one quadratic polynomial will be given and we will be finding zeros, and the second method zeros will be given and we will be finding the quadratic polynomial. So now let's get started. Question 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So now already we have learnt how to find the zeros and how to verify the relationship between zeros and coefficients, isn't it? So now let's move on to the sums. So first subdivision, it is given a quadratic equation is given. First, what have they said? Find the zeros of the polynomial. So this will be the first part, and verifying the zeros, this will be the second part. So first one, we will be doing the first part. So first we will be finding the zeros. So in order to find the zeros, we will be using factorization method. This method we have already learnt in class 9. So this will be easy for us, and once more I will just explain you all. So x square minus 2x, let this be p of x. So p of x is equal to x square minus 2x minus 8. This is the given polynomial. So I will be splitting this polynomial by taking the sum. What is sum? So what is the sum? I have to take this, isn't it? So sum is minus 2 and I will be taking the product. Product will be this one, 1 into minus 8, that is coefficient of x square and the constant. Now, so 1 into minus 8 is minus 8. So now I will be finding the pairs. Okay, so how to find this pairs means, so if I multiply two numbers, then I have to get minus 8, and those two numbers what I'm multiplying, if I add or subtract, I have to get this number. So if I take with, I have to have minus, no, so any one element should have minus. So first let me take 1 into 8, which gives me 8 only, but if I add, what will I get? 9. So I can't take that. So if I subtract also, I will have 7 or minus 7. So next it is 2 into 4 is equal to 8. 2 plus 4 is 6, where 2 minus 4 is minus 2. No? So I will have 2 and minus 4. So what are my pairs? Pairs is equal to 2 comma minus 4. This is my pair, so I will be substituting over here in the place of minus 2. So p of x is equal to x square plus 2x minus 4x minus x. So if I subtract these two, 2x minus 4x is minus 2. So p of x is equal to, I will be taking these two terms together and these two terms together. So here x is common, so I will take x common out, and here x plus 2, and here I will take minus 4 outside, so x plus 2. So minus into minus is, minus into plus is minus, no, so only I have taken here like this. So these two are common, so I can take this common out. So p of x is equal to x plus 2 into x minus 4. So now we have got this, and my zeros of polynomial, I will be taking this x plus 2 is equal to 0, and I will take that p of x is equal to 0. Okay, so x plus 2 into x minus 4. Let my p of x is equal to 0, then I will be just equating it to 0. So x minus 4 is equal to 0. So x is equal to minus 2, x is equal to 4. So therefore my zeros of the polynomial are minus 2 and 4. So let this be alpha. So let alpha is equal to minus 2 and beta is equal to 4. So now I will start verifying the relationship between the zeros and the coefficients. Relationship between zeros and the coefficients. So first I will be taking sum of zeros. So sum of zeros is equal to minus b by a. This is the formula, isn't it? So alpha plus beta is equal to minus b by a. So what was my alpha? Minus 2 plus my beta is 4. So what was my minus b? So minus I will have as it is. My b was minus 2 divided by what was my a there? 1. So minus 2 plus 4 it is 2 is equal to minus into minus is plus 2. 2 by 1 is 2 only. So therefore sum of zeros is equal to minus b by a. So this is verified. So now let's check for product of zeros. So product of zeros is equal to c by a. This was the thing, no? So alpha into beta is equal to c by a. What was my alpha? 2 minus 2 and my beta is 4. So c is minus 8 divided by 1. So minus 8 is equal to minus 8. So therefore LHS is equal to RHS. Therefore verified. So we have verified for sum of zeros as well as for product of zeros. Then we will say that hence verified. That's it. Subdivision 2. A quadratic polynomial is given and we have to find the zeros and we have to verify the relationship between coefficients and zeros. So I have taken this as let p of x is equal to p of s. Okay, so this will be p of s is equal to 4s square minus 4s plus 1. So whatever variable is given, you have to take that variable. So now let's find through factorization method. So therefore I will have my sum as minus 4. This one is minus 4, no? So minus 4 and my product is equal to 4 into 1 is 4 only. So now I have to find the pairs in such a way that if I multiply I have to get 4 and if I add or subtract I have to get minus 4. So if I take 1 into 4 I will have 4, but 1 plus 4 will give me 5 or 1 minus 4 will give me 3. So next if I move on to 2, so 2 into 2 is 4 only. So 2 plus 2 is plus 4, whereas I have minus 4 here. No, so I will I have minus sign here. So minus into minus is plus, 2 into 2 is 4. So this is my required pair. So I will take that p of s is equal to 4s square minus 2s minus 2s plus 1. So if I take subtraction over here, I will add this, no, same sign, add and put the common sign, no, I will get this previous step. So p of s is equal to, I will be pairing these two, this one. So I will take 2s common out. So 2s, so 2s into 2s only is 4s square minus 1 minus, I will take as it is. So 1 only is common here. So 2 yes. Minus into minus is only plus. So I will take minus here or 1. So my 2 yes minus 1 and 2 yes minus 1 is common here. So p of s is equal to 2 yes minus 1 and 2 yes minus 1. So now I will take my p of s is equal to 0. So 0 is equal to 2s minus 1, 2s minus 1. So therefore I will have 2s minus 1 is equal to 0, 2s minus 1 is equal to 0. So s is equal to, I will take this side, so 1 by 2, s is equal to 1 by 2. 2. So now I will take that. Let this be alpha. So alpha is equal to 1 by 2 and my beta is equal to 1 by 2. So now first sum of zeros is equal to minus b by a, isn't it? So my alpha is 1 by 2 plus my beta is also 1 by 2. And what is my b? B there it was minus 4. Minus 4, my a was 4. So 1 plus 1 is 2. 2 by 2 is equal to minus into minus is plus 4 by 4. So 1 is equal to 1. This is verified. Now I will be taking the product of zeros. So product of zeros is equal to C by A. So alpha beta is equal to C by A. So alpha is 1 by 2, beta is also 1 by 2. What is my C there? It is 1 and my A is 4. So 1 by 4 is equal to 1 by 4. So LHS is equal to RHS. So I will say that hence verified. That's it. Subdivision 3, a quadratic polynomial is given and I have taken that as p of x is equal to 6x squared. See here, this is not in a standard form, so we have to write it in the standard form. So only I have written 6x squared minus 7x minus 3. Okay, so now I have written in the standard form. So now let's move on to the solution. So I will be taking the factorization method for this. So what is my sum? Sum is minus 7. So this number and my product is equal to minus 18. So now I have to check what if I take, I will get this one. So I have minus 18 here. No? So my pairs should be, if I take minus 18, I will not get. So next I will be going for 2 into 9. So 2 9s are 18 I will have. So 2 minus 9 or 9 minus 2, I will get minus 7. So what I will get minus 7. This greater number should have minus. So my 9 will be minus 9. So here I will have 2 and minus 9. This is my pairs. So p of x is equal to 6x square minus 9x. Okay, so plus 2x minus 3. So now I will be taking the common terms out. So these two together and these two together. So here what is common? 3 and x. So 3x I will take out. So 2x minus 3 plus 1 into 2x minus 3. So these two are common. So I will take my p of x is equal to 0 now. So 0 is equal to 2x minus 3 and 3x plus 1. So now I will just equate it to 0. 2x minus 3 is equal to 0. 3x plus 1 is equal to 0. So x is equal to 3 by 2. And here x will be minus 1 by 3. So this is the 2 zeros of polynomial required. Now I will take this as alpha is equal to 3 by 2 and my beta is equal to minus 1 by 3. So now I will just take the relationship between coefficient and zeros. So sum of zeros is equal to minus b by a. So alpha plus beta is equal to 3 by 2 plus minus 1 by 3 is equal to minus of what is my b? Minus 7 divided by 6. So I will be taking LCM. So my LCM is 6. So 9 minus 2 is equal to 7 by 6. So 7 by 6 is equal to 7 by 6. My LHS is equal to RHS. So sum of zeros is verified. Now I will be taking for product of zeros. So product of zeros is equal to C by A. So alpha into beta is equal to, what is my alpha? 3 by 2, and my beta is minus 1 by 3 is equal to, C is minus 3 and my A is 6. So this 3 and 3 will get cancelled. So I will have minus 1 by 2, and here also 1 times 2 times, so is equal to minus 1 by 2. So therefore LHS is equal to RHS, hence verified. Subdivision 4, a polynomial is given, that is, I have taken it as P of u. So P of u is equal to 4u square plus 8u, and no constants are given, so I will take that as 0. So this way I will be doing it. So now here we need not to take factorization, okay? So instead we can just take the common terms out, because my constant is 0. So I can't take product and all. If I take sum and product, my sum will be 8. My product will be 0. So I can't do anything. So I will just take the common things out. Even you can do it in this way. P of u is equal to, I will take the common terms out. What is common here? 4 into u, that is common, no? So 4 into u plus 2. So this is what the required. So here 4u into u is 4u square. 4u into 2 is 8u. So that's it. So now I will take my P of u is equal to 0. So 0 is equal to 4u into u plus 2. So I will just take this or split this. So 4u is equal to 0 and u plus 2 is equal to 0. So here u is equal to 0 by 4 is 0 and u is equal to minus 2. These are the two required zeros of polynomials. Now I will take this alpha is 0 and my beta is equal to minus 2. You can take anything, okay? You can take this also as beta, nothing wrong. So here now I will verify. So sum of zeros is equal to minus b by a. So here sum of zeros 0 minus 2 is equal to, my b is minus 8. So plus 8. So minus is already there. So minus 8 divided by 4. So minus 2 is equal to, minus 8 by 4 is minus 2. So LHS is equal to RHS. So sum of zeros is verified. Now product of zeros. So product of zeros is equal to C by A. So alpha into beta is equal to 0 into minus 2 is equal to, what is my C? I don't have C, so therefore it will be 0 by my A is 4. So 0 into something is 0. 0 divided by some number is also 0. So therefore LHS is equal to RHS. So sum of zeros and product of zeros are verified. So I will say that hence verified. That's it. So fifth subdivision, t square minus 15. So now I have taken this polynomial as p of t. So t square minus 15. So in last question, constant was missing. And here the t term is missing. It means that p of t is equal to t square minus 0t minus 15. So this is the form for it. So now what we will be doing is that we will be taking this as a square minus b square. We will be taking this like this. So now we will be taking it as a plus b into a minus b. So we will be taking this 15 as 15 square, 15, okay. So it will be root 15 square. So this and will get cancelled. So it is 15. So if we take it in such a way, p of t is equal to t square minus root 15 square. So this is of the form a square minus b square. Now, so what we will do is that p of t is equal to t plus root 15 into t minus root 15. Okay, so now we will take p of t is equal to 0. So 0 is equal to t plus root 15 into t minus root 15. So now we will just equate it to 0. T plus root 15 is equal to 0. T minus root 15 is equal to 0. So t is equal to minus root 15. So t is equal to root 15. So now I will take this as alpha. Alpha is equal to minus root 15. My beta is equal to root 15. Now I will be doing the sum of zeros. So sum of zeros is equal to alpha plus beta is equal to minus b by a. What is my alpha? Minus root 15 plus beta is root 15 is equal to minus my b is 0 divided by 0 only, no? So 0 t. I said no, so only 0 and my a is 1. So 0 is equal to 0. 0 by something is 0. So my sum of zeros is verified. Now product of zeros is equal to alpha into beta is equal to c by a. What is my alpha? Minus root 15 and my beta is plus root 15 is equal to what is my c? 15 divided by minus 15 is my c and my a is 1. So root 15 into root 15 is 15, minus into plus is minus. So minus 15 is equal to minus 15. So LHS is equal to RHS. So hence verified. That's it. Subdivision 6, a polynomial, quadratic polynomial is given and I took that as p of x. So p of x is equal to 3x square minus x minus 4. So we will be taking factorization method. So my sum is minus 1 and my product is minus 12. So if I multiply any two, I will have to get 12 and the sum should be minus 1. So my pairs will be 3 and 4. So 3 into minus 4. So 3 into minus 4 is minus 12 and 3 minus 4 is minus 1. So I will be taking that. So p of x is equal to 3x square plus 3x minus 4x minus 4. Okay, so if I subtract these two, I will get the previous step. So I will be taking the common terms out. So p of x is equal to 3x into x plus 1 minus 1 into minus 4 into x plus 1. So minus into plus is minus. So only I have written like that. So p of x is equal to 3x minus 4 into x plus 1. So now I will equate my p of x is equal to 0. So 0 is equal to 3x minus 4 into x plus 1. No, so 3x minus 4 is equal to 0, x plus 1 is equal to 0. So x is equal to 4 divided by 3 and x is equal to minus 1. So alpha is equal to 4 by 3 and my beta is equal to minus 1. Now I will be verifying for sum of zeros. So sum of zeros is equal to alpha plus beta, which is minus b by a. So alpha is 4 by 3 and my beta is minus 1 is equal to minus, what is my b? Minus 1 divided by a is 3. So now I will be taking LCM. So 4 minus 3 divided by 3 is equal to 1 by 3. So 1 by 3 is equal to 1 by 3. Now I will be taking for product of zeros. So product of zeros is equal to alpha into beta is equal to C by A. What is my alpha? Alpha is 4 by 3 and my beta is minus 1 and my C is minus 4 and my A is 3. So minus 4 by 3 is equal to minus 4 by 3. LHS is equal to RHS. So sum of zeros as well as product of zeros is verified, hence verified. That's it. Till now we were learning one method, that is quadratic polynomial was given and we were finding zeros and verifying the sum of zeros and product of zeros. Now sum of zeros and product of zeros is given. From that we have to find the quadratic polynomial in each of the given numbers. Okay, so now let's get started. So subdivision 1, 1 by 4 and minus 1. This is sum of zeros and this will be product of zeros for every question. First one will be sum of zeros and the second one will be for product of zeros. So now we have to find the quadratic polynomial. Okay, so I will write that let the required polynomial be ax square plus bx plus c. This is the general form for any quadratic polynomial, isn't it? And its zeros be alpha and beta as it is. So my what is given I will write. So alpha plus beta is equal to 1 by 4. Yes, so my alpha into beta is equal to minus 1. These are given. So these are already given in the question. So now I have to find the what? Quadratic polynomial, isn't it? So I will write the general form as x square. To find quadratic polynomial we will be using this. So x square minus alpha plus beta into x plus alpha into beta. This will be the general form to find the quadratic polynomial. So x square as it is minus what is alpha plus beta? 1 by 4. So 1 by 4 into x plus alpha into beta is minus 1. X square minus x by 4 minus 1. So now I will be taking LCM. So 4x square minus x minus 4 by 4. So in p of x we need not to write this denominator because we will take p of x is equal to 0. No, so when we take like that we will have 4x square minus x minus 4 only. So we need not to write 4 in the denominator. So therefore p of x is equal to 4x square minus x minus 4. That's it. Division 2, here also two values are given. This is sum of zeros and this will be product of zeros, and I have taken this as let the required quadratic polynomial be ax square plus bx plus c and its zeros be alpha and beta. So now I will write what all is given. So what is given here? Sum of zeros, that is alpha plus beta is equal to root 2 and my alpha into beta is 1 by 3. No. So with this I will find the quadratic polynomial. So what is the general form? X square minus alpha plus beta x plus alpha into beta. So this is the general form, isn't it? So x square as it is. What is alpha plus beta? For root 2, no, so minus root 2 into x plus alpha into beta is 1 by 3. So I will take LCM. So 3x square minus 2 root 2x plus 1 divided by 3. In the next step I need not to take here. So my p of x, that is the required polynomial, is 3x square minus 3 root 2x plus 1. This is the required polynomial. So subdivision 3, solution. See, two values are given. This is sum of zeros and this will be product of zeros. So let me take my quadratic polynomial as ax square plus bx plus c and its zeros be alpha and beta. So now I will write what all is given. So given alpha plus beta is equal to 0 and alpha into beta is root 5. So here, in order to find the equation, I will take x square minus alpha plus beta into x plus alpha into beta, which is equal to x minus alpha in plus beta is 0. 0x plus alpha into beta is root 5. So this is x square plus root 5. So therefore p of x is equal to x square plus root 5. This is the required polynomial. So subdivision 4, here also two values are given. This is sum of zeros and this will be product of zeros. So this is the general form any quadratic polynomial and this is the zeros of the polynomial. So I will write what is given. So given alpha plus beta is equal to 1 and alpha into beta is also equal to 1. So now what is a general form? So x square minus alpha plus beta into x plus alpha into beta. This is the general form, isn't it? So now what is x square? I will write as it is minus what is alpha plus beta? 1. 1x plus 1. So now what is p of x? So p of x is equal to x square minus x plus 1. This is the required polynomial. So subdivision 4, here also two values are given. This is sum of zeros and this is product of zeros. So let this quadratic polynomial be ax square plus bx plus c and this is my two zeros. So I will write what all is given. So my given part will have sum of zeros, that is alpha plus beta is equal to minus 1 by 4. No. So next I will have alpha into beta. Alpha into beta is 1 by 4. So now I will just write the standard form, that is x square minus alpha plus beta into x plus alpha into beta. So therefore I will have x square minus 1 divided by 4 into x plus 1 by 4. So now I will just take LCM. So 4x square minus into minus is plus x plus 1 divided by 4. For p of x, we need not write the denominator. So p of x is equal to 4x square plus x plus 1. This is the required polynomial. Subdivision 6, here also two values are given. One is sum of zeros and then it is product of zeros. So let the required quadratic polynomial be ax square plus bx plus c and its zeros be alpha and beta. So now first I will write the given part. What is given? Alpha plus beta is equal to 4. First one, okay. So alpha into beta is equal to 1. What is the general form now? X square minus alpha plus beta into x plus alpha into beta. So this will be x square minus what is alpha plus beta? 4. 4x plus alpha into beta is 1. So the required p of x is equal to x square minus 4x plus 1. This is the required polynomial. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.